Hi guys, today we're going to teach you how to do limiting reactants.
We're going to teach you 2 different ways to find limiting reactants.
And how to find the percent yield.
Okay, so first of all, I'm going to show you how to find the limiting reactant when you have 18.1 grams of NH3 and 90.4 grams of copper oxide with this equation. So first of all, you're going to want to convert both of these numbers to moles. So we're going to start with NH3, and then you have 18.1 grams of NH3, and then you're going to convert it to moles by dividing by the molar mass, which is 17.04 grams per mole, which equals 1.06 moles of NH3. And both of these grams cancel out since you're dividing them. And then you're going to move to copper oxide. So you have 90.4 grams of copper oxide. And then you're going to divide that by its molar mass. And then you have 79.55 grams per mole for copper oxide, and once you divide that out, then you have 1.14 moles of copper oxide. And again, those grams are going to cancel out. And then you're going to use the molar ratio between NH3 and copper oxide to find which one is going to be the limiting reactant. So you're going to do 3/2 for copper oxide over NH3, and then the NH3s are going to cancel, and you're going to be left with 1.59 moles of copper oxide needed. And then you're going to do the same with copper oxide, but you're going to switch the equation so that the copper oxides cancel out. So you're going to have 2 NH3 divided by 3 copper oxide, which equals 0.75 moles of NH3. Okay, and then you see here that this is what you have, and then this is what you need for your reaction to go through. So we see here that we have 1.06 moles of NH3, but then we need 0.75. So you see that this is more than this, so that will be fine in the reaction. But then here we need 1.59 moles of copper oxide, but we only have 1.14 moles. So then we're going to see that copper oxide is going to be the limiting reactant in the equation.
We know that the reaction uses 40.4 grams of copper oxide. So to find how much nitrogen gas we use and how many grams we use, we have to use 90.4 grams of copper oxide and divide it by the molar mass to get the moles. Then once we do that, we go to the balanced equation, and we get the ratio is 3 moles of copper oxide to 1 mole of nitrogen gas. And then you get and then you divide by 1 mole of nitrogen gas, which is 28.2 grams, and it equals 10.6 grams of nitrogen gas is produced.
So the next problem we're going to do is 68.5 kilograms of CO reacts with 8.60 kilograms of H2. We need to find out what the theoretical yield is. And to find that, you need to find the limiting reactant. So we already have the equation here. CO plus 2H2 yields CH3OH. And we're going to need to change 68.5 kilograms of CO to make it moles. But first we need to change it to grams. Oops. Like so. So that the kilograms will cancel out. And then you will multiply this by the molecular weight, which is 28.01 grams to equal 1 mole. This will come out to be 2.45 times 10 raised to the third moles of CO. Then you need to do the same thing to H2. So it's 8.60 kilograms of H2 times 1,000 grams over 1 kilogram, and multiply that by the molecular mass of 2.02 grams to equal 1 mole. And that equals 4.26 times 10 raised to the third moles of H2. Again, grams cancels out and kilograms all cancel out, so you have to put the moles. So then you need to multiply by the molar ratio, which is going to be 1 here and 2 here. And you're going to multiply by 2 moles of H2 divided by 1 mole of CO. And you're going to do, that's going to equal 4.90 times 10 raised to the third moles of H2. So moles cancel out. And then you're going to do the same thing again down here, and you're going to reverse the fraction. And it's going to be 1 mole of CO divided by 2 moles of H2. Again, they cancel out, and that's going to equal 2.13 times 10 raised to the third moles of CO. So this is how much you need in a reaction, and this is how much you have. So as you can see, we need 4.90 moles of H2, but we only have 4.26. So this right here is your limiting reactant. So now that we know that H2 is our limiting reactant, we're going to start with that amount. So 4.26 times 10 raised to the third moles of H2. And you are going to multiply that by the molar ratio between H2 and CH3OH, which is going to be 1 mole of CH3OH divided by 2 moles of H2. This is going to then be multiplied again by the molar mass, so that we can change it back to grams, which is 32.05 grams equal 1 mole, so that the moles will cancel out, and then these moles cancel out, and then you're left with 6.83 times 10 raised to the 4th grams of CH3OH. That is going to be your theoretical. So the next thing we need to answer is, what is the percent yield? And the percent yield equation is the actual amount divided by the theoretical times 100. So they gave us the actual, 3.57 times 10 raised to the 4th grams of CH3OH. And we found that the theoretical was 6.83 times 10 raised to the 4th grams of CH3OH. Now we just need to plug it into the equation. So we use the actual, 3.57 times 10 raised to the 4th grams of CH3OH. Divide that by the 6.83 times 10 raised to the 4th grams of CH3OH. Multiply it by 100, and your amount is going to be 52.3%.